I made a decision this morning. Ready? Drum roll. Decision was that all the level 4s for the rest of the year will be proofs.
Why?
Here's why.
I don't get it.
A proof is not a type of problem, as you've noticed. We're only using old information right now. A proof is not a type of problem, it's a way of doing a problem. So, most geometry books, unfortunately, try to act like proofs are one lesson that you learn one time, and then you just don't do them anymore. And unfortunately, they take a long time to get good at. So, I think a proof is sort of the highest way you can do a problem. So now that we're starting to practice proofs with old information, for all future lessons, we're going to continue by doing the new information in proof form only on what level?
4.
Level 4, okay? Anyway, this is our first proof of the year. So basically, what I did is I wrote a problem that might look familiar. How many of you guys think this problem is familiar?
We do.
Yeah? Why is it familiar?
Warm-up.
It's your warm-up, isn't it? Okay. Now, don't look too much at the warm-up. Just kind of look at this. What it says is given. Measure of angle ACD equals 130 degrees. Well, angle ACD is this one right here. The first thing you should do in any proof is if it tells you a written given, draw it in the diagram. It's the first thing you should always do. The reason you do that is it helps you see the problem better. Does that make sense?
Yeah.
Okay, next. It says to prove that GFH is 50 degrees. Okay, so this is what we're trying to prove. Well, it seems to me that what we got here is parallel lines and a relationship between these angles, right? So what's the relationship between the angles?
Same side exterior.
Same side exterior, okay. So basically, we're going to start by stating given information. So what's one piece of given information?
Angle ACD is
Measure of angle ACD equals
130.
130 degrees. How do we know that?
Because it's given.
Given. And that's exactly right. Anything that is given, either it states it right there, or you can tell by looking at the drawing. Your reason for that statement is just G-I-V-E-N. Is there another thing that's given? In fact, I kind of blew it. It should be this.
They're parallel.
Okay, so how do we say that?
Line BD.
is parallel to
Line EG.
line EG. Okay, good. There are other ways of saying it. It's not essential. But what do we say about that?
Because of the triangles at the end.
Given. Yeah. It's not because of the triangles at the end. It's given, right?
Okay.
It's given in the diagram. Okay. All right, cool. So now we know we have a 130-degree angle. We know we have parallel lines. So I think it's time to start talking about the relationship between these angles, right? First we have to say what the relationship is, and then we have to say what we know about them. So what is the relationship between these two angles? Their position relationship. Okay, so what we're going to say is angle ACD and angle FGH are same side exterior angles. Okay, is that also given?
Yeah.
Yeah, it is. Okay. So now, what do we know about same side exterior angles?
They're
Supplementary. Okay, so what we say is same side exterior angles, SSE angles, are supplementary. How do you know that same side exterior angles are supplementary?
Technically, because you taught it
given.
to us.
It's not given.
Oh.
It's one of these things. So what is it?
It's a theorem.
It's the same side exterior angles theorem. That's all it is. You guys get that? So usually what you're going to write over here is either given or you're going to name a theorem. Does that make sense to everybody?
Yeah.
Okay. So we just write same side exterior angles theorem. Okay. So if they're supplementary, does that mean that we're ready to solve the other angle? what do we put as our last statement? What do we put? Measure of angle GFH equals 50 degrees. Okay. And the reason for that? It's not given. Okay. Just so you know, this will never be given. If this was given, it wouldn't be a problem, right? We had to prove it. So it's not that we proved it. Actually, what did we do? We did math to solve it. In theory, what we did is said, well, that's 130. We know they added to 180, so we subtracted, right?
Yeah.
Okay. Here's what I'm going to do to make all of this very easy. Whenever you've done math in a step, you write
PEMDAS?
This covers all the laws of basic arithmetic, right? So, even though it's just subtraction, you write PEMDAS, it covers everything. If you do the Pythagorean Theorem and solve the Pythagorean Theorem, what do you write for your answer? PEMDAS. PEMDAS. If you do the math, the step where you did the math is PEMDAS. Let's review what this really means. We're saying this one is 130 degrees? Given. Okay, we know that. We're saying these are parallel?
Given.
We're saying that these are same-side exterior angles?
Given.
Given. We're saying same-side exterior angles are supplementary. That means they add to 180. Same-side exterior angles theorem tells us that they are supplementary. Now that we know that they're supplementary, we know that this one's 130, then we had to subtract 180 minus 130 to find 50. So what did we do? We did math. Anytime you did math, great answer, PEMDAS. This is acceptable in a lot of levels. A lot of people will accept PEMDAS because it just means that you're referencing all the math rules that you already know. Does that make sense to you guys? Yeah? You guys want to do a different kind of proof?
Yeah.
All right, let's do a different one. Pythagorean Theorem sound okay? Yes? Yay, we love Pythagorean Theorem. Yeah! Why didn't I think of that? Woohoo! No? That's not happening. Okay. Okay.
I get it.
All right. Okay. So, let's think about this. And sometimes you have to practice something before you really get a good understanding. We're always going to start with our givens. Another thing I'll say, start with your numerical givens. Your givens that are about numbers first. Then start with your factual givens second. You understand what I'm saying? Yeah. Like it's probably better to say PQ equals 6 and PR equals 10 and then follow with, oh, and PQR is a right triangle. Does that make sense? Yeah. Okay. So this is going to be a 5-step proof. Let's try a different approach. What will be my last statement? Don't, you guys keep saying this. That is too general. Be specific. What am I literally going to write? That's what you should be saying. QR equals 8. It's silly to say general answers like that. Say exactly what you mean. Okay. So that's the last thing I'm going to write. What should be the first couple things I write?
PQ equals 6.
PQ equals 6. And PR
Equals 10.
equals 10. Okay. And what's the reason for both of these?
Given.
Given. Okay. And see, there's something that happens when you start writing a proof, especially when the table's already made for you. You start seeing the boxes fill up, the anxiety kind of goes away. You start to realize, okay, we've got 5 boxes filled out without even thinking, right? So we know we're pretty close. What kind of problem is this going to be?
Pythagorean Theorem.
Pythagorean Theorem. Can I do Pythagorean Theorem here, or do I need one more fact before I'm allowed to?
You have to infer that it's a right triangle.
I need to say that it's a 90-degree angle. Could I say it's a 90-degree angle?
Yeah.
Could I say it's a right triangle?
Yeah.
Are they both given?
Yeah.
Yeah.
Does it really matter which one I say? No. So let's say it's a right triangle. How would I say that?
It's a right triangle.
Triangle.
Triangle PQR.
PQR is a right. There you go. Triangle. Good. And how do we know this?
Given. Oh, the
90 degree.
You don't really need to say that. I think it's okay to say given here. I'm not going to be too tight on that because, after all, it's a triangle
and it's given.
and it has a 9-degree angle in it. Sure, you could say, you know, some person would say, definition of a right triangle. You know, because the definition of a right triangle is a triangle with a 9-degree angle. It's given, right? Okay, so now that we've said we have a right triangle, we've stated two sides. Are we ready for the Pythagorean theorem?
Yeah.
So specifically, you got to give the Pythagorean theorem in the format of the names of the sides. So what's the name of this side?
PQ.
PQ. So what I write is PQ squared plus
QR.
QR squared equals, what is it? PR squared. Okay. What am I referencing here? No. The Pythagorean theorem. Okay, the person who said PEMDAS, I want you to realize, right now we're setting up the problem. We haven't solved it, right? What allows us to set up this problem? The fact that in a right triangle, a squared plus b squared equals c squared. Okay, so this means we're allowed to say this. Now, how does that turn into this? We did some math, right? We did 6 squared plus x squared equals 10 squared. Therefore, the answer is 8. So, what do we put as our final step? PEMDAS, because we did the math to solve it. That is exactly correct. What do you guys think? One more or good?
We're good.
Good?
Yeah.
Okay, thank you for watching. Watch again.